All right, so today, even with this upper body program, he tries to throw in some leg days. So today we hit legs. It was a little weird. So we had two kind of warm up sets. Um, we did deadlifts for 4 sets, 8 reps. Bulgarian split squats, 4 sets, 10 to 12 reps, and that was about 45-second rest in between. Then we moved into a circuit. And the circuit was just 3 rounds. No rest in between each exercise, only rest in between each like round. First exercise was crush grip squats, so you're basically just like holding a weight, doing some squats. 12 to 15 reps of those. You then moved into sprinter lunges, 10 each leg, and then finally kettlebell swings. You did 20 of those with about 90 seconds between each round. And today, finally, we went through kind of the nervous system last time, how that kind of worked, how the signal got brought. And now we can talk about how the muscle works, how muscle activates, how it contracts, all that fun stuff. So that signal that we had talked about goes all the way from your brain down through your neurons, and then finally hits this, when it actually gets down to the end of that axon, or like we had talked about, the axon terminal. Actually, once it hits, it'll actually hit these little sacs full of neurotransmitters, which will get released into the neuromuscular junction. So like this little hole where like your axon sits and your muscle sits. It'll release those neurotransmitters onto that area where receptors on that muscle actually pick them up. And those neurotransmitters will tell them to either they can either be excitatory, which means they cause the muscle to contract, inhibitory, which actually means it like repolarizes the muscle even more, so it makes it like more negative, so it doesn't reach threshold, or it will actually do nothing, and so nothing will change. But if the signal does get received, it's going to go down through these things in your muscles called T-tubules, where its only job is basically to be like a big like wire, basically like deep into your muscle, so that all those muscle fibers can fire. So what actually happens is it goes down, the signal will go down into your T-tubules. It'll hit these little electrical receptors, which will send that electricity into the sarcoplasmic reticulum, which will release calcium into the muscle. And then we'll go into our little sarcomere, where you have our classic, myosin, actin looking things here. That calcium will attach to troponin on actin, which will open up these binding sites for myosin to actually grab onto. So once those are opened up, your little myosin heads will grab onto those handholds, and it will actually kind of pull it once it breaks off ADP. So it'll be kind of like a half grab, and then once it releases that phosphate that's on it, it'll be like a full grab. Then ATP will come back in, make that head release, so grab back up top. And then, the ATP will make it release. And then once that's broken down into ADP and P, you'll see the system move once again. So like when you're doing deadlifts or Bulgarian split squats, you'll see that happening. And one thing to note is when we are recruiting those muscles, we have a few different muscle fiber types. And so if you're doing like a deadlift, it's going to try to recruit those smaller muscle fibers first. So that's why kind of if you go up to a weight set and you're going to pick it up and you kind of jerk and like, oh, this is way heavier than I thought, and then you're able to pick it up, you just kind of misjudged how many muscle fibers you were going to use. So you started off using those small muscle fibers, and then as you needed the more force, you started recruiting the bigger ones. So yeah, it's today.